As we've seen over the last few lectures, there's a lot of damage done by earthquakes. One of the questions could be, how is it that the earthquakes actually cause this damage? Faulting and shaking are obvious. We've seen some video, we've seen some still images of examples of faulting and the damage done by the shaking. We can also have landslides and ground failures. In the case of Mexico City, the ground failures were due to the ground being jello-like, the old lake bed. Landslides dump material onto existing structures or onto people, onto animals, onto roadways, railways, into ports. Important structures are covered with debris. Tsunamis, as we saw in the recent video, can devastate large regions. And in the case of the Boxing Day tsunami, it devastated countries all around the entire Indian Ocean. Fires, in the case of the San Francisco earthquake, we saw what happens when you sever gas lines, electrical lines, and water lines in an earthquake. You knock the buildings down, you expose them to electrical discharges. A lot of people use coal and wood at the time for heating. Those fires would have been thrown open. Fireplaces would have been destroyed, chimneys were knocked down. Without the water supply, there's no way to put the fire out. If you notice at the very end of the one Market Street video after the earthquake, you'll see an old steam engine running on the road. That was used to pump seawater from San Francisco Bay up to help put out some of the fires. So people were still relying on steam engines 100 years ago in San Francisco. This is an example from the Marina District of San Francisco of ground failure. This was one of the places to be. It still is, I guess. But the buildings were put up on debris from the 1906 earthquake. Essentially, trains were installed that ran from the destroyed part of the city to San Francisco Bay. These were debris trains. They would fill them with junk from the fire and the earthquake, broken material, animals, everything went into these trains, got dumped into the bay. And then real estate agents said, hey, there's all this property here. It's conveniently located. Let's put buildings on it. And just like Mexico City, you shake that material and the water mixed with all this debris makes for a jello. In this case, a San Francisco jello that destroyed the apartments and condos of the Marina District. When we look at a list of the great earthquakes of human history, in this case really only going back about 1,000 years or so, we can see that the biggest one, the human toll was concerned, took place in China in 1556 with an estimated 830,000 deaths. This was a long time ago. Records are very bad today. You can imagine they're probably even a whole lot worse 500 years ago. So who knows what this really is? It could have been much greater. The earthquake was estimated to be a magnitude of about 8. In 1976, returning to China, we have an earthquake that caused an official death toll of 255,000, whereas more independent international aid workers estimated the death toll closer to 700,000 from an earthquake with an estimated magnitude of 7.5. Now, more recently, from the video we just saw, in Sumatra, Indonesia, the Boxing Day earthquake and tsunami resulted in the death of around 230,000 people from a very, very large earthquake, one of the top 3 in human history, as far as we know. Estimated here at 9.1. It's been revised recently to be 9.2-ish or so. And there's a pretty big difference between 9.1 and 9.2. In 1138, Aleppo, Syria, now famous for the ongoing military activity there, 230,000 people perished in an earthquake with an estimated magnitude of 7.1. Close to the recent, about 10 years ago in Haiti, an earthquake struck that killed an estimated 222,000 people and displaced 1.3 million people from an earthquake of a magnitude 7.0. I was doing some field work in the Dominican Republic just shortly after this, and we were on the border, the Haitian border, for, I don't know, maybe an hour or so, and got to see the tragedy that resulted from this earthquake. People desperately trying to get out of Haiti into the Dominican Republic, being turned back by soldiers. We saw a woman taken off of a bus with her children, kind of beaten by the soldiers. I didn't take any photos or videos of any of that stuff. But Pretty depressing. In 1927, again, China, 200,000 people were killed in an earthquake estimated at 7.9. In 856 CE, in Iran, an estimated 200,000 people were killed from a 7.9 magnitude earthquake. Back to China in 1920, another 200,000 people killed in a very, very large earthquake, 8.6. In 893, back to Iran, or maybe not, 150,000 people were killed from an earthquake estimated to be somewhere between 6-ish and 7.5 or so. Recently, it's been discovered that there may have been a clerical error in transcribing the documents in the Middle Ages, and this resulted in Armenia being mistaken for Iran, this town in Armenia being mistaken for this town in Iran. So this earthquake may have actually taken place here rather than here. And records weren't so good back then. 1923, Kanto, Japan, 143,000 people were killed by a 7.9 magnitude earthquake. And then just wrapping this up for now, in 1948, in the former Soviet Union, Turkmenistan used to be part of the Soviet Union. It's not part of Russia now. In Ashgabat, 110,000 people were killed from a magnitude 7.3. So one of the commonalities here is that generally the high death tolls are associated with poor regulations, poor building codes, or total lack of building codes. Now the question is, can we reduce earthquake risks? The answer is quite possibly. We can do this through land use policies, prevent people from building in places that are doomed. And this comes about from hazard characterization. So some hazard geologists come in, take a look around, tell the engineers what the issues are going to be, and work with them to come up with an emergency plan. This emergency plan will include earthquake engineering. This is building buildings, bridges, ports, other structures to proper code that can withstand most earthquakes. There's unlikely to be much you can do about the very, very large earthquakes, but we can certainly prevent death and property damage in smaller earthquakes. Here's an example of poor land use planning from California. This is construction along the trace of the San Andreas Fault, which runs basically through here. You can see a bit of the superficial expression here in this water body. So most likely the fault runs through here as opposed to over here, but that's a minor point. So the reason people are willing to live on something that's going to destroy their house is they're basically placing a bet. This isn't going to happen until I'm gone. I like the weather. I like it when it's 23 degrees and sunny almost every day of the year. So I will take a chance living on a fault zone. In Japan, tsunami barriers have been put up in what are thought to be hazardous areas or prone areas. And this was the case with Fukushima, but the barrier wasn't high enough in the case of Fukushima. So the tsunami got over the barrier and destroyed the nuclear power plant. And you know the rest of the story. California, for example, where we have a earthquake-prone society, a very large population. The population of California is much larger than the population of all of Canada. We identify potential hazards in our homes and begin to fix them. Hazards would be keeping your bowling ball collection on top of a high cabinet in your house. Bad idea. Bowling balls will roll off onto you or your coffee table or anything else that's below the bowling balls. Get heavy things off of your ceiling. Create your disaster plan. What are you going to do when the earth quakes? What do you need? Create your disaster kit. You need water, you need batteries, you need food, things like that. Number one, identify your building's potential weaknesses and begin to fix them. In California, a lot of people bolt or screw their cabinets into the walls so that when an earthquake does strike, the cabinet doesn't flip over. You've got your bowling balls off the top of the cabinet. That's a good first start. Now, bolt your cabinets to the wall so they don't cruise around your living room looking to fall on you. During an earthquake and aftershock, drop, cover, and hold on. So get away from things that will fall on you, broken glass, bricks, bowling balls. and hold on to something. You're going to slide all over the place potentially. After the shaking stops, check for damage, take care of any injuries that may have occurred. When you're safe, follow your disaster plan. Get out your flashlight, your batteries, your water, your food, and figure out what you're going to do next. In reducing earthquake risks, one of the things we're going to have to do is map out seismic hazards. Where is it dangerous to live? Where is it safe to live? And this involves an assessment of seismic risks. How much risk do you want to take? Here is a global seismic hazard map. Where you see red, you can expect to have earthquakes, fairly significant earthquakes. So in a lot of parts of the world, it all makes sense. We have mountain ranges here that run from Ushuaia down here up to Kodiak Island out here in the Aleutians. That all makes sense. The land is all crunched up here, and if something's sticking up, an earthquake probably did it. Same thing here in the Caribbean. We have a very complicated tectonic situation resulting in lots of earthquakes in eastern Cuba, Haiti, Dominican Republic. In Europe, well, it's all bashed up tectonically. Turkey, Southern Europe, we got volcanoes, we have earthquakes, we got it all, plus some good weather. Iran is just kind of an earthquake mess. The entire country is an earthquake zone. And the same thing associated with the Himalayas. All the high mountainous regions in this part of the world are prone to very large earthquakes. And Indonesia, not only famous for the volcanoes, as we've seen in previous lectures, also big earthquakes. And it's because of all the active tectonic business going on here. In the United States, take a little bit of a closer look. This is the San Andreas fault system here running through California. You'll notice that it's not dark brown. It's not the most hazardous area in the United States. We're actually much more prone here in the boot heel. This is the boot heel of Missouri. So down into Arkansas, Missouri, along western Tennessee, western Kentucky, southern Illinois, all of this area is going to be shaken to smithereens at some point by the reactivation of the New Madrid Fault. Here we have a bit of an oddity in South Carolina, where occasionally we have very strong earthquakes. This is an interplate earthquake here, and we have interplate earthquakes here up by the Gaspé Peninsula. Alaska, very active subduction along the Aleutians here. This is an island arc of volcanoes, so we expect that activity. Hawaii, also active volcano, active seismically. Now we talked about Molokai cracking in half about 1 million years ago or so, and this northern half falling off into the Pacific. Same thing is starting to rear its head here on the Big Island. There's a big crack, a great crack that runs across Hawaii that is known as the Great Crack. At some point, Hawaii is going to crack and part of it's going to fall into the Pacific, generating the biggest, baddest tsunami that anyone can imagine. The expected loss in terms of money and life is going to look a little bit different. Now, there are lots of people living here along the West Coast. And again, they live out here because of the weather and a number of other reasons. Not many people living here. This is a fairly poor, I'll say extremely poor area of the United States. Fairly poor compared to other countries in Europe. So not many people live here. Not much money is invested in this area, except for Memphis, Tennessee here, St. Louis here. So this will be shaken, but not stirred. Not going to stir up a huge financial loss compared to what would happen out here in San Francisco or LA or Seattle or Portland. Now, can we predict earthquakes? The short answer is no way. The longer answer is, yeah, we know where earthquakes have occurred in the past. If we can figure out how often they occur and with what periodicity, we can make a prediction about when they're going to occur again. Intermediate term earthquakes, we're so-so. We fully expect San Francisco to be hit by an earthquake at some point, probably in the next 100 years, but we don't know when. Short-term earthquakes, no idea. We may see foreshocks that are indicative of a coming earthquake, or they may just be minor shocks that aren't followed by an earthquake for 20 or 50 years. That's still a problem. So we're trying, but we're not quite getting there yet. Now, we developed a technique isotopically to look at clams in the past. So we've started out with an earthquake in Oman. It was about 856, I believe, was the year. There was also a cyclone in Oman that hit Oman around that time. So we're able to differentiate between the clam being killed by a cyclone, the clam being buried by an earthquake, or dying of natural causes. If all the clams show the same date of death, that means they were probably all buried in the same event. We actually see that by using robots to take samples of clams that died in 856 in Oman in that case. If we do that enough in enough different parts of the world, we can begin to predict much more accurately when earthquakes have occurred in the past and when they will occur in the future.